What exactly is a container? Why do we use them? Why are they such a buzz when it comes to cloud computing? And how are they different from traditional virtualization technologies? That's coming up next.
Welcome to Tech Topics brought to you by Cybervenger. We help keep small businesses stay protected and compliant with cutting edge cybersecurity and IT solutions.
All right, well, we'll skip to the punchline here. A container is a middle layer of computing that allows you to bundle applications and resources into a single thing they call a container. It's analogous to a virtual machine. Now, I come from an era before virtualization even existed, where if you had a file server, a domain controller, an SQL server, application server of some kind, you would have to physically buy a server, slide into a rack, or stick a desktop on a shelf somewhere for each one of those things. Or you could buy one server and you could just load a bunch of roles on it. So you could take a Windows box and you could install the Active Directory role. You can install DNS server role. You can stick file shares on it. You could install SQL server on it. You can install applications on it. I mean, you can have one piece of hardware with one operating system running a bunch of stuff. Virtualization really wasn't necessary to have a single piece of hardware do all these different things. The problem is if I'm running a web server and a database server and some other custom applications, they start fighting each other, there's an opportunity for different applications to clash, to conflict with what they need. Maybe one needs a version of some prerequisite that's different from what another one needs. Plus, there's optimization. The memory optimization in an operating system is different for when you make a file server than if you're running an application server. In fact, there's even settings in Windows to adjust for what your server role is. At least there used to be. I haven't checked for that in a long time, but I digress. The point of virtualization is that you can now have an entire operating system on that same piece of hardware multiple times, one for a domain controller, one for a file server, one for an SQL server, another for a web server, so on and so forth. And they can be completely optimized and configured. They can run different versions of .NET from each other, not have .NET. They could run more complex firewall on one, less complex firewall on other, different types of antivirus. You can do all this different stuff, and you could patch them and reboot them one at a time without affecting the others. Of course, you have to patch and reboot the hypervisor underneath it at some point, but nothing's perfect, right? Then there's clustering to solve that problem, but I digress. But getting back to the original thought, what if I just stuck a bunch of roles on an existing server? You can do that. And along comes containers, and that's kind of what a container is. It's sort of a halfway point between a virtual machine and a server with just a lot of jobs stuck on it. Picture domain controller, DNS, SQL, web server, file server, blah, blah, blah. Only what it does is it creates a separate memory environment. It creates a separate environment that's not entirely separate. It still shares the same kernel. So you would have a kernel running on your machine that would run the operating stuff, would talk to the disk, talk to the memory, run threads. But then you would have a different set of variable names, a little bit like a user session. When you log into the desktop as a user, you get an environment that has variables. Like I could create a environmental variable like path, the path variable, and I can change it from my user. It won't affect other users, even though we're all on the same operating system. Drive mappings. I can have drive mappings as a user. Doesn't affect other users when we're logged in. Anybody who uses a terminal server kind of gets the idea. If you're from a terminal server world, it may be a little easier for you to wrap your head around what a container is. That's what did it for me. Like like a user session, except that instead of a user, it's at the server. It's an isolated environment for running a server rather than a user session. But similar concept. You're still sharing the same kernel. You're still sharing the same memory and stuff, but it's an isolated section of memory. It's walled off from a security standpoint, so in theory, you can't mess with any of the other machines. It acts like a separate machine. You can't read and write the memory stack. You can assign how much resources it's allowed to use. So one machine, one container can't gobble up all the RAM or all the CPU on your computer. And when I say computer, I mean both physical and virtual. We'll talk about that in a minute. So you could do that, and that helps out a lot with giving you all the benefits of a virtual machine without all the operating system overhead. Because every time you run a virtual machine, you're running another copy of the operating system, and there's always some RAM overhead. And they did tricks in VMware and Hyper-V and all the Hyper-V and all these other hypervisors to try and reduce that. Like there's memory sharing and stuff like that, deduplication of memory. But if you're running a copy of, say, I don't know, Windows 2016, Linux, like Ubuntu Linux, simulated Mac. I'm going to try to give a bunch of different examples of different stuff. Each one of those is going to have a full overhead of an operating system. Now, you can do multiple copies of the same operating system. It's like Windows 2022 in multiple instances, and there's a lot of sharing that goes on. But those are kind of band-aid tricks to make virtualization less wasteful than it otherwise would be. Containers do that kind of automatically. Here's an interesting point about containers. Your container host, again, it's very much analogous to a virtual host, has to run guests, or containers is the proper term, that are the same operating system. So you cannot run Windows containers on top of a Linux host. You can also not run a Linux operating container on a Windows container host because they're sharing the kernel. The kernel has to be the same. Security ramifications. If somehow you were to have an exploit for the kernel, you can exploit all the containers at once because they share the same kernel. So it's not as strong as a virtual machine. But it's still better than having a bunch of services on one computer. A virtual machine is kind of like a computer, but it's not, you don't have a separate desktop. You have, if you want an Active Directory domain controller, we wouldn't really have that in Linux. Well, yeah, you have, there are Windows containers too. So if you want a domain controller, I have no experience with Windows containers. I've really been practicing on Linux, so I'd be butchering this, but I presume you could have an Active Directory container and a file server container, just like you would, yes, because they're all sharing the same kernel. At least conceptually, that's what you would use it for. You can have a directory server under Linux too. You can have an LDAP server. You can have a domain server. You can have a web hosting server. You can have database server, various applications, whatever, in different containers, and you can reboot them separately, which is interesting because it's all the same kernel. I'm like, how do you do that? In experimenting with, there are two containers I've seen. Docker is one, and LXC, if you're using Proxmox, is another. I've been working with LXC on Proxmox. What I find interesting is you can have, Proxmox is essentially Debian, and the containers would thus be Debian Linux kernels. I have, however, loaded Ubuntu as a container on top of Debian, and you could do other Linux flavors, same kernel. It's the kernel that has to be the same. Everything else is different. So you can end up with a different shell environment. You can end up with different libraries installed. You can end up with different amounts of RAM or CPU priority. That, just to give you an idea of the differences between one container versus how isolated a container is. It really is that middle ground between a full guest and just loading the heck out of a single operating system with all the services you want to use. It's kind of isolates the session, isolates the amount of memory. For me, I only really understood what a container was when I started working with it, seeing the limitations. I created an open VPN server, which we see in other videos do that on container, and I couldn't get it to work because it couldn't talk to the TUN device in the operating system. It was locked by the container. Now, there's a way I could have worked around that, but I decided that was too much trouble. I just did a virtual machine for my open VPN. But again, as an example of things you could do with a virtual machine that you can't do with a container, or at least have to stop and think about. Hopefully that makes that a little more clear. So from a security standpoint, a whole virtual machine guest is better than a container, which is better than a single operating system with a bunch of applications installed on it. But could you do both? And you can, and a lot of places, in fact, do. Why? So you can have a virtual machine on a hypervisor that itself is a container host that has containers on it. That's a classic thing to do in multi-tenant environments. So again, when I told you, if you jailbreak a kernel, all the containers are now vulnerable, right? But containers use a lot less overhead than a virtual machine. So there's trade-offs there. So what you do is you would create one virtual machine as a container host per tenant. So for customers, one container gets broken and they are able to exploit the kernel and trash all the other stuff. It's still just that one isolated customer. It's not all your other customers. But you're still getting the resource savings, the efficiency of running containers. If you got 5 or 6 containers, those containers are lightweight. It'd be a lot better than having 5 or 6 guests in terms of performance and system overhead. So that's why they do that. And you could do all guests, and people do that too, but it costs more resources. And like reboot times on a container like that, it's so fast compared to an operating system from scratch, because a lot of stuff is already running, initialized. But you want to isolate that from tenant to tenant is a good example of where you do that. And maybe even your own environment, you want to do that. You want to take a production container host, it's one guest, and a quality control, and maybe a development or whatever. Maybe you got one virtual machine that runs containers that your customers use, one for your in-house stuff, so on and so forth. Just give you an idea where that architecture would come from. Of course, you can always still run full hardware if you're crazy and jam a bunch of services on it. But when you reboot, you lose your whole network, and the conflict potential is very, very high. So if you need to do something like that, I think containers really are the way to go. They're good to work with. You can get started. You don't have to be a cloud person to appreciate containers. I found if you use Proxmox, and we've got videos on Proxmox out there, enabling an LXC container is very easy. Just right-click and create it. You get to download containerized images. That's basically your install disk. Like, think when you create a virtual machine, you download an ISO for Windows or Ubuntu or SUSE Linux or whatever the heck you're going to put on there. Same thing with containers. Your container image is like an ISO, but it's customized to run. And Proxmox will show you the list of containers that you can use on that kernel. And so you can pick it that way and know that they're all going to work. And there's a surprising variety, all Linux, of course, but would have thought one distribution from the other might fight, not be similar enough to be a container. But that's not the case. A lot of distributions, again, giving you an idea just how separate a container is from, like, say, just a user session. So in terms of isolation, you've got one piece of hardware. You got the hardware level. That's the absolute most separated. You've got virtual machines. That's the next most. Then you've got containers. Then you've got user sessions. So most to the least separated, if that helps you understand what containers. Anyway, I hope this video helps somebody out. This is kind of a little notes for myself as to what a container is, as I'm starting to use them more and understand them with security. So hopefully that helps you out, and we're going to probably make more videos on how to do a container, how they work down the road, and we'll see you in those videos.
Welcome to Tech Topics, brought to you by Cybervenger. We help keep small businesses stay protected and compliant with cutting-edge cybersecurity and IT solutions.